1.6 Part B. So, solutions of absolute value inequalities. Consider the graph of the solutions to. The absolute value of x is less than 2. So, let's just choose some values and see if they work. Here's our number line. Let's choose -5. If you take the absolute value of -5, do you get a number that's less than 2? Nope, you sure don't. How about -4? Absolute value of -4 is +4. That's not less than 2. 3, -3. The absolute value is +3. That's not less than 2. The absolute value of -2 is +2. That's not less than 2, but we're so close. What about -1? The absolute value of -1 is 1. That is less than 2. That works. What about 0? It works. Absolute value of 0 is 0. That's less than 2. 1, sure, that works. 2, so close, but not quite. What about 3? The absolute value of 3 is 3. That's not less than 2. That doesn't work. 4, no. 5, no. So our solution consists of just those numbers between -2 and 2. The absolute value of x is less than 2 is a compound, the solution is a compound inequality. It's between -2 and 2. So what about this problem? The absolute value of x is greater than 2. Let's do the same thing. Let's find the values that work. What about -5? The absolute value of -5 is 5. That is greater than 2. That works. -4. That works. -3. What about -2? The absolute value of -2 is 2. That's not greater than 2, but it's close. -1, is absolute value of -1 greater than 2? No. 0? No. 1? No, those don't work. What about 2? It doesn't work, but it's close. 3? That works. 4 and 5. So our solution will be the numbers on the right and the numbers on the left. This looks like a union problem. We have the right end or the left end. So now let's look at our rules for any positive number p and any algebraic expression x. The solutions to the absolute value of x is less than p, and that's just very similar to the absolute value of x is less than 2, are those numbers that satisfy x is between -p and p, just like we had x between -2 and 2. So our absolute value is less than, we will have an intersection. We'll have x ranging between values. The solutions of the absolute value of x is greater than p are those numbers that satisfy x is less than -p or x is greater than p. That's like the absolute value of x is greater than 2, and we had two solutions. We had x is less than -2 or x is greater than +2. So when it's the absolute value is greater than, we end up with the ends of the line. So let's use that information to work these problems. The absolute value of 4x minus 1 is less than or equal to 5. It's less than, so 4x minus 1 is between -5 and 5. We have to solve this inequality for x by isolating x in the middle. We have 3 different locations. We need to get rid of that 1, but we can't just add 1 to the middle. We have to add 1 to all 3 places. negative 4, 4x, 6. We still need to isolate x. We need to get rid of that 4. So we want to divide by 4, but we have to divide by 4 all 3 places. 6/4 is 3 halves, that's 1 and 1/2. So let's graph this on a number line. We have negative 1, we have 0, we have 1 and 2. X can be equal to negative 1. It can be equal to 1 and 1/2. And it can be anywhere in between. What is the interval notation for this solution? Well, we need to begin at 1, end at 1 and 1/2. Include the endpoints. How do we do that? Square brackets. Let's look at our next example problem. Absolute value of 2y plus 9 is greater than 13. How do you do absolute value is greater than 13? Is greater than 13, you have to look at both ends of the number line. So greater than 13 on the right-hand side, or 2y plus 9 is less than negative 13 on the right-hand side. We need to solve these individually. Looking at our first inequality, we need to isolate the y term. That gives us 2y is greater than 4. Isolate y. Y is greater than 2. What about the other inequality? How do we solve it? y is less than negative 22. What next? Y is less than negative 11. So, let's graph that on the number line. Negative 11 is smaller than 2. It goes to the left. Y is less than negative 11. Y is greater than 2. Interval notation. What's our interval notation for y is less than negative 11? Or what's our interval notation for y is greater than 2? One more example. We would like to solve this inequality. You cannot solve an absolute value inequality until the absolute value has been isolated. How do we get rid of the 5? We've isolated our absolute value. How do we solve this? It's greater than, so it's on the endpoints, so our x minus 3 is greater than or equal to 8, or the x minus 3 is less than or equal to negative 8. Let's solve both of these inequalities. Solve the first one. X is greater than or equal to 11. Solve the second one. X is less than or equal to negative 5. Let's put that on the number line. -5 is less than 11, so we'll put -5 to the left. We want to graph x is less than or equal to -5. Y is greater than or equal to 11. Interval notation. What's our answer? Parenthesis or square bracket? Or 11 to positive infinity, parentheses or square bracket? Always use parentheses with positive and negative infinity. And that concludes our 1.6b. Move on to the next tape if you need to.